Welcome, my name is Philippe Zek and this webcast accompanies my book Data Analysis. In it, I will show you how to detect and correct heteroskedasticity in a regression. Suppose that we've run a regression. One of the questions we ask ourselves is if our results are reliable. Now, this is measured by the standard errors of our coefficients. However, these standard errors can themselves be biased if certain methodological problems exist. For example, there might be heteroskedasticity, which means that the variance of your residuals is not constant. So we have periods with low variance of our residuals, which means that they are very reliable, and high variance of residuals, which means that they are less reliable. OLS will ignore this difference and therefore create standard errors which are actually not correct. Usually the reported standard errors will be lower. So how do we detect this problem? Well, we go to View, Residual Diagnostics, and then heteroskedasticity tests. Depending on your eViews version, you will see a myriad of options. The test of choice for this book is the white test. The white test uses the residuals, and better said residuals squared, as a dependent variable for an auxiliary regression. So it tries to find a pattern in the variance of your residuals by squaring them and regressing them on the independent variables. Let's have a look at the results. We press OK and we get the following output. Now, this auxiliary regression is shown in the second part of the output. As said, the dependent variable are our squared residuals. Independent variables are the same independent variables we have in the original regression, but also their squares. We might actually also use cross products, as we have over here the market times the VIX or the market times the WTI, for example. Any of those variables, combined, squared, or single, should not give us a significant result. We see here that several actually do. So there is heteroskedasticity in here. We can also see this in another way. The R squared of this auxiliary regression should be 0. In fact, it's almost 1. So these are both strong indications that there is heteroskedasticity. We can see this more clearly if we look at the top part. We see an F statistic, which says the joint significance of all independent variables in the auxiliary regression, which rejects its null hypothesis. P-value is well below 5%, in fact it's 0. We also can use the R squared of the auxiliary regressions, if multiplied by the number of observations, as an additional test. It gives us the same answer. So we have a heteroskedasticity problem here. The next question is, of course, how to solve this. For this, we go back to estimate. We want to re-estimate the same model, but with the heteroskedasticity correction. For that, we go to Options, and under Coefficient Covariance Matrix, we look at the drop-down list. Estimation default corresponds to OLS. If we use, however, the white algorithm, it will correct for heteroskedasticity. It will weigh each observation, each residual, based on its variance. So we press OK, and we once again get output. Now we get actually new output with the added line white heteroskedasticity consistent standard errors and covariance. The coefficients remain the same, but the standard errors have now changed. They have been recalculated, which has an impact on the t-statistic and the probability values. In fact, we now are left with no significant independent variables at the 5% level. So our conclusions actually change due to the heteroskedasticity correction. This is not always the case, but it happens often enough that you really want to test for any heteroskedasticity in empirical data and correct when necessary.